Lagging stock technical indicators are used to follow price movements by identifying uptrends or downtrends. They consist of simple moving averages, exponential moving averages, Bollinger Bands, and parabolic stop and reverse, among many others. Moving averages are overlays that smooth stock price data to identify trends. Simple moving averages and exponential moving averages are the most popular. The calculation of simple moving average is as follows. It is equal to the sum of n number of close prices. N is the number of days for which we want to calculate the corresponding moving average divided by those n number of periods. To calculate exponential moving averages, the current exponential moving average is equal to 2 divided by n plus 1. Again, n is the number of periods for which we want to calculate the corresponding exponential moving average, which is then multiplied by the difference between current close minus previous exponential moving average, and to this result we add previous exponential moving average. For our initial exponential moving average, it is equal to the simple moving average of those n corresponding periods of close prices. Great. So let's go back into our Python PyCharm IDE so that we can study moving averages with greater detail. Excellent. So here we are back within our Python PyCharm IDE. In this lecture, we'll be working within simple moving averages and exponential moving averages code files. If you have any questions about their setup, please go back to section 1, Stock Technical Analysis Data lecture, where all of that explained with greater detail. So let's begin with simple moving average. As all of these are meant to be standalone type of files, then the first part is we import our packages. We import NumPy as MP, Pandas as PD, Matplotlib as PLT, and Talib as TA. Then we proceed to do our data reading by default. For this, we create SPY data frame, which is equal to PD or pandas.read_CSV, and within it we supply the path to our corresponding data, which in this case is found within our project in the data file stock technical analysis data.txt, which corresponds to those CSV or comma separated values. Then we have index column as dates, and we parse those dates as true. Next, we are going to calculate our corresponding technical indicator. For that technical indicator calculation, we have SPY. We create the column within brackets, which is SMA5, and we calculate it with Talib's TA.SMA, and within it we use NP, which is numpy.asArray for SPY, and here we select the close values, and here comma 5 because it's for 5 days. Something very important. This is commonly used for weekly type of calculation, but you can modify it according to your needs. Then we do our corresponding chart here, which is SPY.plot, and here within the vertical axis Y, we choose within brackets close, comma, SMA5. Then we add a title to this chart, PLT.title, SPY close prices, and simple moving average SMA5. We locate that legend at the upper left and we show the corresponding chart. So let's proceed to run this code. This is done by clicking the right button on the mouse and then scrolling down into Run Simple Moving Average. Once it's stored right here, we can just select the file and run it. So here we have our chart. So let's make it at the full screen. I need to do it manually because we are within the screencast. So from here all the way into here and up to here. Perfect. So this corresponds to our chart. We have the title, SPY close prices and simple moving average. Then we have on the vertical axis the corresponding prices. On the horizontal one we have those dates from the beginning of 2016 to the beginning of 2017 as mentioned. Then regarding our legend, those blue lines corresponds to close prices and the orange one to that simple moving average, which as we can see it is a smoothing of our corresponding data. If we would like to zoom into any part of this chart, we just select this part right here and, for example, select this area so that we can visualize with a greater detail. Also, if you focus on the lower left right-hand corner here and use the mouse on top of any of the lines, you'll see the precise coordinates of those values. Excellent. So you can also scroll back your zoom, and we're going to close this chart. We have other charts which we'll study in our following sections. Excellent. So now that we finished with simple moving average, it's time to continue with our exponential moving average here. So we double click in this file as well. We scroll all the way into the beginning. Has similar mechanics as it is a standalone type of file. Therefore, we first import our packages as we did previously. Then we read our data again with the same mechanics. And then we proceed to do the corresponding technical indicator calculation. Notice the difference. In this case, we are calculating two exponential moving averages, one for 5 days and another one for 21 days. In both cases, we are using Taleb's EMA, which is different to that SMA we used before, and we're using NumPy, which is NumPy as array for our close prices in both cases, and we are providing 5 days and 21 for the other one. Whenever you have two moving averages, this can be considered as the fast one and this as the slow one. Also, this is conventional for weekly type of moving average and this for monthly one, but you can also modify these values and adapt them according to your needs. So the chart again is spy.plot, close prices, EMA5, EMA21. We give it its corresponding title. The legend is located at the upper left, and we show the corresponding chart. So let's proceed to run the code again by clicking the right button on the mouse and scrolling down into Run Exponential Moving Average code file. Excellent. So we have our chart again. Let's make it as a full screen. Again, needs to be done manually in this case because of the screencast. And up to here, there we are, and also right into the bottom. So here we have our chart with its title SPY Close Prices and Exponential Moving Average for 5 and 21 days. Vertical axis are prices, horizontal dates from the beginning of 2016 to the beginning of 2017. Focusing on the legend, close prices are colored in blue. Then we have the shorter term moving average in orange and the longer term one in green. As we can see, both of them do a smoothing of our data, but the longer the period we have, such as in the green line, the more smooth that the data becomes. Excellent. So we're going to close this chart. Also, these other charts which we'll study in following sections. Excellent. So let's continue with our lagging type of indicators. In our next lecture, we'll study Bollinger Bands, and that is going to be our following objective.